Good morning, guys. Today we're going to do a little review of mechanical advantage with levers to help you out with the sheets that I'm going to post. So first we'll start off with a review of the formulas. One of them is output force divided by input force. I actually prefer to call it load force divided by effort force. The two formulas mean exactly the same thing. They're both formulas for achieving mechanical advantage. They're just using different words. Okay, so essentially what you can get from that is that the output force is equal to the load force and the input force is equal to the effort force. Okay, and then the other one that we're going to use today is length of effort arm divided by length of load arm. Okay, so just a little review of the classes of levers, and that's just to remember where the fulcrum is in case you ever have to draw your own picture. Okay, so in a class 1 lever, we have the fulcrum in the center. We have examples here, a seesaw and a pry bar. Oftentimes in a question, it will be like a board that needs to be used as a pry bar. Okay, for a class 2 lever, the load or resistance is in the middle, and that would be an example. And examples of those would be wheelbarrows and nutcrackers. And then class 3 lever tends to be sports equipment, body parts, things like that. So golf club, hockey stick, baseball bat, and in that case, the effort is in the center. Okay, so let's move on to our first sample question. And here it is. Okay, so Aiden uses a wheelbarrow to move some soil to the backyard. The soil weighs 300 newtons. The effort required to move this load was 60 newtons. What is the mechanical advantage of the wheelbarrow? What is given? The load force is equal to 300 newtons. The effort force is equal to 60 newtons. What are we finding? Mechanical advantage of the wheelbarrow. Okay, so in this case, we don't really need to draw a picture, and we'll just go straight to the formula, which is MA equals load force divided by effort force. And in this case, we have 300 newtons divided by 60 newtons, which gives an effort force of, mechanical advantage of 5. Okay. So the MA equals 5. Therefore, the mechanical advantage of the wheelbarrow is 5. Oh, forgot to slide it up. Okay. So we have our formula, our mechanical advantage, and lastly, we have our statement. Okay, the next question. Notice here that the newtons cancel each other out, so there is no unit. Okay, next question. I have a diagram for you. Okay, let me slide it. And here I have a little bit of information. So I have a lever. It is a first class lever in this case because the fulcrum is in the center. So we have two possibilities here. Okay, there's fulcrum A and then there's fulcrum B. Okay, so we've got a bunch of measurements. We'll have to refer back to those in a minute. The question is, Jacob used a board to lift his tires into the back of his pickup truck. The tires had a weight of 400 newtons. What is the mechanical advantage of the lever with the fulcrum in each of the above positions? How much force will Jacob need to use to lift the tires with each lever? Okay, so obviously it's the same lever, but with the fulcrum in a different place. So what do I have here? We have a bunch of information. So first, it's a first class lever. There are two possible fulcrums, fulcrum A and fulcrum B. Okay, so when we have fulcrum A, the length of the effort arm is 3 meters. Length of the load arm is 3 meters. Okay, for fulcrum B, the length of the effort arm is 5 meters, and the length of the load arm is 1 meter. Okay, so if I go back to my picture, let me just slide this up like this. There we go. We can see that the full board is 6 meters. When we have the fulcrum in position A, the effort arm is 3 meters, the load arm is 3 meters. Okay, when we have it in position B, the effort arm is 3 plus 2, which is 5 meters, and the load arm is only 1 meter. Okay, so first we need to find the MA of each lever, we'll call it that. And we also need to find the amount of force for each lever. Get that I made for each into one word. Okay, so let's go on to the next page. All right. So let's start with our formula. And in this case, let me see. Okay. MA equals length of effort arm divided by length of load arm. Okay, and so this is fulcrum A. And here we have 3 meters divided by 3 meters. Those meters cancel out, and so we get a mechanical advantage of 1. Okay, and if I want to find the mechanical advantage of, the effort force for fulcrum A, then I would use the same formula. You would use MA equals load force divided by effort force. Okay, and if I look back on the question, I can see that the weight of the tires is 400 newtons. I know the mechanical advantage of this system is 1, and I don't know the effort force. Okay, so I can simply multiply both sides by effort force, because if I look at 400 newtons divided by effort force, I want to make sure that I am doing the opposite of division in order to balance the equation. Okay, so I'm going to times both sides by effort force. And so I get 1 effort force, or just effort force, equals, these cancel out, 400 newtons. So we talked in the past about the idea that an MA of 1 equals no MA, or in other words, the load force will equal the effort force. Okay? All right, let's look at fulcrum B. Okay, so MA equals length of effort arm divided by length of load arm. And in this case, we have 5 meters divided by 1 meter. Falling off the table here. Okay, and meters cancel out, so we get an MA of 5 divided by 1, which is 5. Okay, so let's plug it into our other formula again. MA equals load force divided by effort force. The load force of the tires is still 400 newtons. We don't know the effort force. We do know the mechanical advantage is 5. I'm going to do the same thing as above. I'm going to multiply each side by effort force. It cancels out on that side. And so then I get that 5 effort forces equals, or 5 times effort force equals 400 newtons. What do I need to do? Well, I only want to know what 1 effort force is. So I'm going to do the opposite operation. So 5 times effort force, the opposite of that is divide by. So 5 divided by 5. 400 divided by 5, these cancel out, and I get an effort force of 80 newtons. Okay, so you can see that in this situation, fulcrum B would be the better mechanical advantage, and therefore would require less effort force to move those tires. And that supports the idea that we talked about a few weeks ago, that as you increase the length of the effort arm, then you increase the mechanical advantage. Okay, so hopefully that was a good review and you can start on some of the questions. See you later.